This is a continuation of section 5.3, and we are going to continue to solve equations. At this point in time, though, when we solve equations, we are going to be solving them for all solutions, not restricting them just in the interval of 0 to 2 pi. All right, well, you're going to just do your inverse operations, so let's subtract the 1, and then divide by -2. Get 1/2. When does cosine equal to 1/2? That occurs in quadrant 1, pi over 3. And if it occurs in quadrant 1, because cosine is positive, it also would occur in quadrant 4 with the same type of reference angle. So that would also be at 5/3 pi. All right, I'm going to go ahead and show you what I mean by finding all solutions. If I have a solution here at 5/3 pi, I would also have a solution if I go all the way around. If I go all the way around again, and it would be at 11/3 pi. And let's make this not 5/3 pi, let's make this pi over 3. I don't know why I was doing that. Pi over 3 here. So then if I go all the way around again, it's 7/3 pi. And if I go around again, it's 13/3 pi and 19/3 pi. Well, we need to include all of those solutions. So for a way for us to include that would be if you take pi over 3 and you add to it 2 pi times an integer n. This would include all of those solutions that occur at pi over 3 right here. We can do the same thing for 5/3 pi plus 2 pi, so that goes all the way around the circle, times n, and n would be representing an integer. Okay, so there's your list of solutions, including, again, it's multiple solutions past the first interval of 0 to 2 pi. All right, sine x plus 1 equals negative sine x. So I'm going to go ahead and combine my like terms here. That's 2 sine x plus 1 equals 0. Just going to subtract my 1 here. 2 sine x equals negative 1. Sine x would equal negative 1/2. When does the sine equal negative? The sine is negative in quadrants 3 and 4, and it's going to be a negative 1/2. Sine is your y value, so here and there. All right, this angle would be 7/6 pi. So 7/6 pi plus 2 pi n. And 2 pi n, again, would take you around the circle again and again, and it keeps doing the circular pattern. And the other time that it occurs is at 11/6 pi. So plus 2 pi n. When you don't restrict your domain, then you have to go ahead and add the 2 pi n. And you might be times when you add pi n, it just depends on what your angles are that your solutions occur at. All right, we got tangent to the second x minus 3 equals 0. So tangent squared x, just move the 3 over, take the square root, plus and minus, that means we're going to be in all 4 quadrants, root 3. Let's see where we're going to be at. So tangent with the root 3 occurs at the 60-degree angle and all of the reference angles that are 60. So there's the 4 angles that are, again, when I say the reference angle, what I'm referring to is the 60 degrees away from the x-axis. These are the reference angles. They're all the same. They all have the same ordered pairs going around the outside, except for your signs change depending on the quadrant that you're in. But we know the tangent is then at pi over 3. Here's how I can write my solution. So pi over 3, I can actually add, to go from pi over 3 to quadrant 3, I can just add pi. And then I can add pi again to get back to it. And I can just keep adding pi. So plus pi times n. My second angle occurs at 2/3 pi. So I can do 2/3 pi and add to it pi n. And what that would do is that would, again, start here at 2/3 pi If I add pi to it, then I'm getting to quadrant 4. If I add pi again, I'm back to quadrant 2, and pi again, I'm back to quadrant 4. So you keep getting the angles in quadrants 1 and 4, 2 and 4. All right, those are your solutions there for example 4. And with all the solving that we're doing, here's your assignment. This is the assignment for just the solving here, so section 5.3.